So, you're studying for the AWS Cloud Practitioner exam, and let's be honest, the database section can feel like a lot to take in. Well, today, we're going to cut through the noise. We're going to focus on three specialty databases that you absolutely need to know: Redshift, ElastiCache, and Neptune. By the end of this, you'll be able to tell them apart, no problem. Here's the game plan. First, we'll talk about why AWS has so many different databases to begin with. Then, we're going to do a deep dive into Redshift for analytics, ElastiCache for speed, and Neptune for complex relationships. And to wrap it all up, we'll put them side by side so you can lock these concepts in your brain for exam day. All right, let's kick things off with our first section, purpose-built AWS databases. The whole idea here is pretty simple. One size definitely does not fit all. I mean, it's a fair question, right? Why doesn't AWS just have one huge do-everything database? Well, it's because a single tool rarely solves every problem perfectly. You wouldn't use a hammer to unscrew a bolt. Instead of giving you a Swiss Army knife that's just kind of okay at everything, AWS gives you a set of specialized power tools, each one perfectly designed for a specific job. And this right here is a phrase you have to remember for the exam: purpose-built. It's the core philosophy. It's all about using the right tool for the job. You need analytics? You use a data warehouse. You need speed? You use an in-memory cache. You need to understand relationships? You use a graph database. Each one is a specialist. Okay, on to our second section, Redshift, the data warehouse. This is your go-to tool for business intelligence, especially when you need to crunch numbers on just massive, and I mean massive, amounts of data. Okay, exam tip right here. If a question mentions data warehousing, business intelligence, or running complex analytical queries, your mind should immediately, automatically, jump straight to Redshift. Those are your keywords. So what's Redshift's secret sauce? How does it handle all that data so fast? Well, first, it uses something called massively parallel processing. Just imagine trying to solve a giant puzzle, but instead of one person, you have 100 people working on different sections at the same time. That's MPP. It also uses standard SQL, so it feels familiar if you've ever worked with a traditional database. And this is a huge one. You can scale your compute power and your storage separately. That's a massive cost saver, because it means you only pay for the processing power you need, right when you need it. And this Duolingo example is just perfect. They're not just storing data about what users click on. They're analyzing billions of events every single day to figure out how people actually learn. That is the classic Redshift use case, taking a mountain of raw data and turning it into incredibly valuable business insights. All right, section 3, ElastiCache, the speed layer. We're shifting gears now. We're moving away from analyzing huge amounts of historical data and focusing on making your live applications faster. We're talking pure, unadulterated speed. Okay, here's a problem every developer faces eventually. Your app is getting sluggish, and it's because your main database is getting hammered with the same read requests over and over again. Things like a popular product's details or a user's profile info. Making the database fetch that same hot data every single time creates a bottleneck. And that's exactly the problem ElastiCache was built to solve. You know, the best way to think about ElastiCache is like your application's short-term memory. It keeps all the frequently used stuff in RAM, which is ridiculously fast. This takes a huge amount of pressure off your main database, freeing it up to do the important work, like writing new data. This diagram shows you exactly where ElastiCache lives. See? It sits right between your application servers and your database. When your app needs some data, it checks ElastiCache first. If the data is there, we call that a cache hit, it gets a response in microseconds. If it's not there, a cache miss, no big deal. It just goes and asks the main database like it normally would, but then it stores that answer in the cache for the next time someone asks. Now, with ElastiCache, you get a choice between two engines, Redis and Memcached. For the exam, here's the easy way to remember it. Think of Redis as the versatile, feature-packed option. It can handle complex data and can even save data to disk. Memcached, on the other hand, is a specialist. It's a simple, screaming fast in-memory cache, and that's it. Simple and fast. Okay, on to our final service, Amazon Neptune, the relationship database. This one is built for a really unique kind of problem. A problem where the connections between your data points are actually more important than the data points themselves. So, here are your exam triggers for Neptune. If you see a question that talks about social networks, recommendation engines, or fraud detection, anything that's about navigating complex relationships, your brain should just scream Neptune. It's a graph database designed to connect the dots. And here's why that's so important. Imagine trying to ask a traditional database a question like, show me all the restaurants that my friend's friends also like. Honestly, that query would be a slow, complicated nightmare. But for a graph database like Neptune, that's what it was born to do. It excels at finding those hidden connections and patterns that are almost impossible to spot otherwise. All right, let's bring it all home. We've looked at all three services, so now let's lock in that knowledge with a direct side-by-side comparison. Think of this as your ultimate cheat sheet for the exam. Okay, this slide right here is your golden ticket. If you remember nothing else from this explainer, remember this. Redshift is for analytics, ElastiCache is for speed, and Neptune is for relationships. Say it with me. Analytics, speed, relationships. Redshift, ElastiCache, Neptune. Burn that into your memory. So, as you head into your exam, just remember that core idea we started with. It's not about memorizing names, it's about understanding why each of these tools exist. They are purpose-built solutions for specific problems. And now that you can tell them apart, you are ready to handle any scenario that exam can throw at you. Good luck.